All right, any questions? So let me run through the ODP really quickly. So this is a solution to inserting between the second and third nodes. So malloc a new node, right? We already talked about that. So I'm calling my new node temp, and PTR I'm using as the pointer to the first node. And then it's the following three lines. So, well, temp arrow data equals num. That's just putting the number that we're passing to edit to in the number part of that field. But let's look at these two pointer pieces of magic. Temp arrow next equals pointer arrow next arrow next, and pointer arrow next arrow next equals temp. Right, this could be a children's nursery rhyme or a Dr. Seuss poem or something. It's nonsensical. Temp next equals pointer next next, pointer next next equals temp. Okay, so let's take this apart and see what's really happening. So our standard linked list and our new node temp and pointer is the first node, and we've already loaded the data part of temp with our number, and these two lines should insert temp between the second and the third node. Well, temp arrow next, that's this next block, the bottom block of our new node. We want that to point to the third node. And we're setting it equal to pointer arrow next arrow next. Well, pointer arrow next is saying take the thing that pointer points to and give me the field called next. That's the contents of this, which is the address of the second node. So the thing in parentheses I've drawn will resolve to the address of this middle node. And when we say that thing's address arrow next, we're saying look at what that points to. Give me the contents of the field called next. That's the contents of this. Well, what's in that block? The address of this third node. So we're saying take this block and load in the address of this third node that's building this arrow. And then we change PTR next, which is this block, to be equal to, PTR next next. So again, PTR next is this block, which means the address of this node. Take the thing that points to the next field, which is this, and set it equal to temp, which is the address of our new node. So this changes and points to our new node. And so we got pointer, original first node, new node, and then original third node. Now there's easier ways conceptually to do this. This is a two-line version, but again, like we said yesterday, we could call this PTR, we could call this first, or we could call this second, and we could call it third. And second is just PTR arrow next, third is just second arrow next. And then we just have to say second arrow next equals temp, temp arrow next equals third. And that works great, right? That's just as good a solution. But being able to write these arrow, arrow, arrow chains is going to be really useful, especially when you start talking about trees, which will be in a few weeks. And once you work with this notation enough, it starts to feel like the right way to think about these things. This is PTR, arrow next is the following node, arrow next is the following node. If I threw an arrow data after this, I would be talking about the data field in this third node. And once you make that connection, right, this is the only way you're ever going to think about pointers again, is just dereference and grab a piece of the field. This is also the reason that we have this arrow notation, because suppose I want to say take the thing that PTR points to, take the thing that that points to, and give me the data field. Okay, PTR is our first node, this is our second, third, this is the data field of the third node. But remember, we can also do this without the arrow notation. Instead of PTR arrow next, we can say dereference PTR and give me the next field. And to find what that's pointing to, we can dereference this and give me the next field. And to find the data value of that node, we can dereference that and give me the data field. This you can look at and pretty much figure out how this relates to your picture of nodes once you're used to it. This is kind of a nightmare. Probably not for a computer, but for us this doesn't sort of ring naturally. And what happens if I move this dot like over there instead of out there? So that's why we have this arrow notation that's synonymous with, you know, star, pointer, dot field. So work with it, right? And think about what it means, and it will make more sense over time, and it really helps you working with structures once you're thinking of it in terms of these arrows. It's a good thing. All right. One of the other differences is between PA1 and PA2. PA2, you're going to want to free all of the memory that you malloc at the end. Okay. When you delete a node, you can free it right away. But at the very end of your program, when the person says exit, before you just kick out of the main program, you want to free all the memory that you malloc. Right? All the memory you malloc should be sitting in that linked list. And so you need to free each of those nodes. And we didn't worry about it in PA1 because it was just, you know, elements in an array. But how do we free the elements of a linked list, especially considering that once we free a node, it's gone. We can't use it anymore. So if my list, yeah?
Oh, I was going to say you can traverse it with the one you just passed.
Yeah. So we're going to have to work one ahead of what we're freeing. So if this is a pointer to the sentinel node, I can't just start off by saying free PTR because then I have no way to get to the next node. So I have to move to the next node and then look back and free the pointer. Okay, so this is walking through a muddy swamp without leaving a trail. Right, there's a trail down there of stones. Step on the second stone, reach back, pick up the first one. Step on the third stone, reach back, pick up the second one. When you're done, you're at the other side. You haven't had to step in the mud yet, but there's no stones left behind you. That's basically the algorithm. And so we can take the code for, say, printing, right? So this is still PA1 code. Basically, we're going to print a node. Well, we can't free it at this point, right? Because we need to use its next pointer. But we could do the next best thing. We could take this thing, pointer arrow next, and we can save that into temporary. And once we've got that saved, we can free pointer. So the idea is start off with this first node, right, which will be a sentinel node for us, and temp equals pointer arrow next. Okay, once we've got that, we know where this thing is located. Now we can free pointer. And now we can set pointer equal to temp. So now our pointer is here, and we can just keep looping. Save where this points, free this thing, and then move your PTR variable over here. And after you freed the last node of your list, and you set pointer equal to what that next was, PTR will be null. That's when you know you're done. So it's not that hard. It just takes some thinking about and maybe some trial and error for edge cases. But make a picture of a short list and go through your pseudocode and catch the edge cases. Free the last node, but don't try to free the node after the last.
How do we tell if everything is free from this?
You gotta know,
Okay.
right? So Valgrind will know because it's cheating, but there's nothing you can do inside here to tell you if you've succeeded or not.
You know if you did it wrong because it'll error out.
If you do it really wrong, it'll error out, right? You'll seg fault. But in your code, you just have to, every time you delete, free the memory. And then when you're ready to exit, the only thing that should have been malloc should be in this chain of nodes and go through and free them. But once you think you've got this right, then you're going to run your program through Valgrind. Did we talk about Valgrind in this class? No. Oh, boy. Okay. Let's do some Valgrind then. So Valgrind is the answer you were looking for, I think. I wonder if I talked about it in the last class. All right, so I'm going to at least have to be pointers. So I'm going to have a pair of integer pointers, I and j, yeah.
Extra equal sign on the first I.
Oh, good, thank you. I wonder what the compiler would do with that. It probably wouldn't even complain.
Nope.
I'm going to try that.
It'll take hours to find that.
Yay.
Oh, good luck finding that.
I usually don't make that mistake. That's even harder to find, I think, than the other one. Yeah, so it's saying compare I to this. And it's not assigning I. Nice. All right, so I and j are pointers. Give I 10 bytes of memory. Give j 20 points of memory. Give I 10 different blocks of memory. So I got memory leaks in here, right? I'm leaking 40 bytes at least. And when I run it, right, it runs fine. Nothing happened. Okay, so here's how you test your program for memory leaks. Valgrind, and then the name of your program. So however you would normally run your program, just put the word Valgrind in front of it. And when your program exits, you'll get a bunch of output. Hold on. I don't have Valgrind on my machine. But the server does. Okay, so compile up your main program, Valgrind your main program, and when it exits, you get a bunch of information on there. And it tells me at exit I had 40 bytes allocated in 3 blocks. Those are my 3 calls to malloc. And leak summary definitely lost 40 bytes in 3 blocks. Okay, if you see any of this stuff, you got a memory leak, which will cost points. If you get warnings along the way, you may not have a memory leak, but you're doing something wrong. Okay, so Valgrind is really useful to make sure that you're doing dynamic memory correctly. So what do we do? Free I, free j, and down here after I do another malloc, I'll free I again. So now when I run my program, here's what you want to see. All heap blocks were freed, no leaks are possible. Okay, that's your success message. So in use at exit, 0 bytes and 0 blocks. Total, I did 3 allocations, I did 3 frees, I allocated a total of 40 bytes. That was my 10, 20, and 10. If I try to free j again, which I already freed, I get errors. Now my program did not abort, but I'm getting a message up here which says invalid free, delete, delete, or realloc. And there's not a whole lot of directly useful information in here, but somewhere inside main, I tried to freeze something inappropriately, right? Pay attention to these, because even if your code looks like it works, there's possibly a landmine being set up somewhere. And I'm good at finding those, fortunately or unfortunately.
But that doesn't accept user input, right?
Yeah, you can put in user input. You can run your program totally normally. It should work as before. It's a really cool program. It basically hijacks malloc and free so it can do some extra housekeeping.
So does 3 have like a return value that tells you any of this information?
I don't know, but you know, we can find out. So free returns a void. Yeah, you're right, it does not.
The only reason why I know this is because I looked at malloc 20 minutes ago.
Okay, cool. All right. So I'm going to switch gears, and I'm going to do something I've only done once in my life in CSE 222, and that was an hour ago. I'm going to give you a PowerPoint presentation. And I don't do a lot of PowerPoint, but we need to talk about this. So, so I put together a talk, and the subject is plagiarism and cheating. And these are two different things. And I'm going to mostly talk about plagiarism. And usually in the course of teaching the CS sequence, right, over fall, winter, quarter, you know, 2 or 3 times maybe I'll see a situation where people are turning in code that looks really similar, and there's some sort of sharing going on. Okay, that's usually plagiarism. Once in a great while, I'll stumble across cheating, which is where somebody is buying code, or you know, doing something that very knowingly to them is different from writing the code themselves. But PA1, this came up several times, and we need to get this under control right away. Okay. Definitely for this course in 223, but absolutely before you transfer to a university. So I put together this set of slides the other day, and I just want to kind of talk about different aspects of this. So so accusations are something that I don't usually make. I'm really, really hesitant to accuse someone of cheating, and I'm pretty slow to accuse somebody of plagiarizing, even when I've got pretty strong evidence, right? Because you always want to kind of believe, well, you know, maybe they both channeled Elvis, and Elvis was writing code that day, and right? But mostly I know that students are really trying to do this work on their own. They're trying to learn the concepts. They're trying to understand what's going on, and I respect that, and I applaud that. So I don't like making accusations. Here's a horrible quote. I look at this code and I look at you and I just don't see the connection. Right? Could you imagine somebody telling that to a student? Basically saying, you don't look smart enough to write good code. Right? That's like really horrifying. So I was on the receiving end of that comment a number of years ago when I was an undergrad. And that was me on the left. And the person who made this accusation was teaching the course. He was a part-time teacher. He worked for the government, and I guess in his office, programmers didn't look like this, right? Particularly the branch of government he worked for. And he didn't talk to any other teachers, all of whom knew me and had known me for a number of years. He didn't ask me any questions. He just basically looked at my code and looked at me, and you know, that's what I got on the top of my paper instead of a grade. And I was the only one who turned it in on time, too. He gave the whole class a 1-week extension, which probably made him more suspicious. So I don't like making accusations, okay? I'm pretty sensitive to this. And so I want to try to avoid situations where I need to decide, you know, is this something inappropriate going on?
Did you get
So,
that fixed, or
did it what?
did you get that graded?
Oh, yeah. Yeah. So what is plagiarism, right? Plagiarism we usually hear of in terms of things like writing papers, reports, things like that. And there's a general rule of thumb called the 5 consecutive word test. If you have 5 words in a row that are the same as in some other paper, that's enough to trigger a flag and potentially say this was plagiarized. 5 words. It's not a lot. Not a lot of words. There's 5 words. Okay. Now it's not legislation. It's a rule of thumb, but it's where the alarms start to go off. And I've known cases where this was applied very indiscriminately. Somebody who had done a term paper and the teacher found something in the literature that had a 5-word sequence, and they were technical words, and the person was accused falsely, and eventually managed to be exonerated. But it was a pain, right? But we have this problem with code, right? How many people here have ever written the statement for I equals 0, I less than 10, I plus plus, right? So did you plagiarize from each other just because, right? I mean, it's harder in code because there's only so many ways to code a bubble sort, for example, right? Which is a fairly, involved algorithm, nested loops and all that. So another aspect of plagiarism is how something is structured. So you can have a paragraph which says, here's point A, here's point B, here's point C. Taking those together, we can conclude X, right? And you might have another paragraph with completely different words, but the same point A, point B, point C, suggesting we take them together and concluding the same X, right? And because the structure of those arguments are identical, that can be considered plagiarism. Right? Now, it's not automatically, but it starts that process going. And so this is potentially a problem in code, right? If you were tasked with developing an algorithm for something, and you write your version of the algorithm and somebody else writes their version of the same algorithm, right? You can look at these things and say, yeah, different variables, different indenting, different structure of the loop, but exactly the same steps, right? Well, if the algorithm was supposed to be your own, that can be considered plagiarism, okay? Now, that's not a problem here because I'm always giving you the algorithms, okay? I'm not asking you to invent a linked list or to figure out how to delete a node from a linked list. We're trying to learn that in this class, right? It's very much an algorithms component of the course. But, in other courses where you're trying to come up with things on your own and they're more complex, that can start to be a problem. So I want you to work with each other, right? I still encourage you to work together, try to understand the concepts, ask each other questions, work things out on the board, things like that. I think that's really useful. You just have to be aware that there's a line you have to watch out for. So I would say you're absolutely safe working together on algorithms, definitions, concepts, okay, especially in this course. Because that's what we're trying to learn in the classroom here. That's what I'm lecturing on. That's what's in your notes. That's what's on the videos, right? So what the heck did he say about deleting from the end of a linked list? Is that a special case, right? That's all great to work with people on, try to understand together. Potentially a cautious area is pseudocode, right? For this course, not a problem because we're giving you pseudocode during the lecture, and it's in the book and it's on the slides and all that kind of stuff. So you're safe with pseudocode here. But in more advanced classes, at a university, for example, this can start to be a bit of a gray area. But pretty much guaranteed to be a danger zone is actual code, right? So if you're actually looking at somebody's code or they're looking at your code, you're probably in a really bad area that you want to get away from as quickly as possible, because that can get you into trouble. And part of the problem is once you see a piece of code, you can't really unsee it, right? Especially if you're struggling with it. I can't get my thing to free the memory in my linked list. I keep seg faulting, or I keep having memory leaks, and you're working on this, and you've got all the pieces ready to fall into place, but there's something that's missing. Can I see how you did it? And you look at somebody's code, and bang, it all clicks in your brain. perfect sense. I have to work one node ahead of the one I'm freeing. Now I get it, right? Well, you just turned all of this stuff in your brain into a perfect working solution, but guess what? It's the other person's code. And you can go off and you can code that up yourself now and never look at their code again. Chances are it's going to look a whole lot like their code, right? Because your brain figured it out, and our brains are not wired to say, I answered this question I've been working on for 6 hours, but I'm going to try to find a different solution instead, right? So inadvertently, you can end up writing the same person's code, right? Even though it's coming out of your brain, right? Your brain has seen that, and you can't really unsee it. So I've seen reference to the Gilligan's Island technique, where after you see someone's code, go watch 3 hours of Gilligan's Island reruns. And it will flush your brain of anything useful, and then when you sit down to code, you'll be writing the stuff yourself. And that may or may not work, I don't know, but good reruns. But here's the danger, right? At a university, usually your submissions are electronic, and one of the first things that happens is they go through plagiarism detection software. And this will take pairs of submissions and compare them to each other, and it will completely ignore things like variable names, comments, spacing, indentation, whether this while condition was tested before that or after, right? And it will try to figure out if these are coming from the same source. And chances are, say again?
How would it do that, ignoring all those things?
Probably the same way I do it, and I don't know how to describe that. And maybe not as well as I do it, or maybe better. But there's just ways that you can tell, right? And once you suspect this, then you can start doing more detailed analysis. People have been writing these things for decades, and they've gotten really sophisticated. And they exist for, term papers, reports, things like that. Again, designed to get beyond, well, this person started the paragraph 2 spaces in, so they're different. They're pretty good. And a lot of times, if 2 things get kicked out as being identical, 0 goes in the grade book automatically. Nobody even looks at the submission beyond that. And you go to your grading system and you look and there's a 0. And then you got to start the process of, why do I have a 0? That's best case. Worst case, you might get an F in the course right away. Depends on the teacher's policy and what they've stated. And probably, honestly, it depends on how annoyed the teacher is at dealing with this. And they might just decide, from this point forward, 2 reports the same, you both get an F, right? And that can happen. And you might not just get kicked out of the course, you might find yourself sitting in front of the honor board. And this happened to my friend who was accused way back in the 80s of plagiarism. She found herself in front of an honor board. So what's that like? Basically, you're trying to document your work. So if you've been using Git, you have a record of all your submissions, all your changes, all your mistakes. Mistakes can be really useful for this, right? And you're talking to friends and people who know you and saying, can you come and testify on my behalf? You're getting letters from past teachers who can say this person's a good student, they work really hard, they have good integrity. You're trying to build a case to show that you weren't cheating and that you didn't knowingly help somebody else cheat. Because maybe you wrote the code entirely on your own, and at some point, somebody, took a look at your screen, took a picture, and typed it in. And one function in this thing, somebody else turned in verbatim that matches yours, and, now you're trying to explain why that happened. And maybe you can't, so you're trying to explain why they should believe you that you didn't knowingly do this. And that's no fun. And while you're doing that, you're trying to keep up with your other coursework, right? And you're taking a full load of courses. You're hoping that you can still get through this course, but you're not allowed to come into the class. You've been locked out of the learning system, so you don't have access to notes, assignments, things like that. You're hoping your friends will help you out and so on. And you got this cloud following you around of, my life might be taking a very serious change in direction in the next few months, right? It's really not fun. And best case, in the end you're exonerated, but you've already, lost out on this course. You have to take this course again, which may not be offered for a year, and everything that's a prerequisite for it is going to have to get postponed a year. And you're looking at another year of your life when you're in school, paying money to the school instead of out in the workforce getting paid and having weekends and evenings to yourself, right? It's really not a good situation. Worst case, you can get expelled from school. You can get expelled on first offense. Through no fault of your own, right? Somebody copied your code, you can get expelled, which means you don't have your degree, you're not on a path to get your degree, and every time you go to an interview, talk to a school, try to do something to move further on your path, it's going to degenerate into this conversation about, tell me about what happened at so-and-so when you got kicked out of the program. And you're not going to be able to hide that fact just by not mentioning it on your resume. It's going to come up, and that's a pain. So what do we do about this? Do something different, okay? If what you're doing isn't working, do something different. So some suggestions, right? Work with other people, but only on like concepts, algorithms, and to some degree pseudocode. But write your code alone, okay? Don't team program with somebody else, taking turns at writing pieces of it and then split it up. Don't let anybody see your code. Don't give them a printout. Don't let them see printouts. Don't let them look at your screen. Now, I'm not saying be paranoid. I'm not saying get a screen protector and bark at anybody who walks behind you, okay? But be aware that it is possible that somebody will come by and take a picture of your screen. Think of it like your credit card, right? You probably wouldn't leave your credit card just sitting on the desk next to you. And if you're going to go out to the nerd cave and get a cup of coffee, you probably wouldn't leave your credit card sitting there. Lock your screen, right? It's a little bit paranoid, but it's easy to do. Keep your Git repositories private, right? Keep me as a reporter on the ones that I need to grade, but don't get in the habit of just making all your code, while you're taking a course in particular, making all your code publicly available. Right? Because if somebody wants to cheat, they will find it. And it can hurt you as much as it hurts them. And in case something does happen, right, it's useful to have Git history. So keep using Git. There's another reason for using it. Make sure you understand your code and your algorithm so that if somebody calls you in and says, this is a fantastic algorithm, tell me how it works, right? You can make at least a pretty good faith effort to explain, why you did this or what part you didn't understand and how that's reflected in your code and so on. Comment your code, right? In my case, some of the comments in my code helped me exonerate myself. And if in doubt, just ask, right? I accidentally looked at so-and-so's code and now I think my code looks like theirs. What do I do about it, right? Well, come and have a conversation with me. And I'll make a note of it, and if the code's identical, maybe I'll ask you to write it a different way, or I'll ask you to explain it to me, and we'll go on from there, or something. But we're trying to figure this out, right, before it gets to a situation where it seriously hurts you. So just some things to keep in mind. And again, it's my belief that most students are seriously trying to learn the stuff and are taking the course seriously and doing their own work. And that's what that part of the talk addresses. But I want to talk a little bit about the other end of the spectrum, which is cheating. And I'm not saying this because I'm worried about this. There's very few cases in the CS sequence here where I've encountered people who are outright cheating. But I want you to be aware of what's going on in some of the aspects of this. So this starts largely with places like Chegg, right? So these are, quote, educational sites where students who are struggling can post questions and helpful experts will give you some tutoring, right, to help you do your physics homework or whatever. But in reality, they're mostly used as just cheat sites. You upload questions, you upload homework, and for a fee, somebody will post an answer. And these are used a lot. Not in most cases in this class, but across the spectrum they're used a lot. And it's big business, it's very well structured, it's very affordable, and it's very well known, right? So people are aware of this, and there's things happening to try to control this, right? Washington and Oregon both have criminal statutes on file now about things like selling term papers, selling solutions to assignments, selling dissertations, right? These things are being criminalized, which is a good step. But you're fighting a very compelling industry that's very large and well organized and funded. It's a very hard thing to do. So what can you find on Chegg? Here's a random entry. In this assignment, you're going to implement a linked list using an array of structures as described in class. This problem has been solved. See the answer. Click on that. $14.99 later, you got the code. Somebody else posted the same assignment. They got a slightly different version of the code. And it's just a click away. This is not going to be assignment 3 this quarter, but it was last winter. So assignment 3 was dealing with stacks and queues, implementing these structures using linked lists. Well, there's a solution for that. CSE 215. Write a program dealing with sets. Well, this was fall's assignment for 215. And you can get the answer there. Hey, look at that. Add a new node between the second and third nodes of a list. There's ODP 210. So ODPs are one-day problems, right? So this is sub 24-hour turnaround. That's pretty good. That's better than you get from me sometimes. And you know, you just post the code and somebody will happily help you out with it in exchange for a little money. And this is ridiculous, you know, because the ODPs in particular, they're a tiny fraction of your final grade, and they're really there to help you, you know, learn the material and understand where you are with the understanding. You know all of this. And I can't understand the long-term game plan of buying solutions to ODPs, right? What do they expect is going to happen on the final exam? Unless they've got, like, you know, a really tiny phone with a really fast turnaround. So that's Chegg, right? And there's Essay Taste. Hey, ODP 210 is on that site too. And there's Academic Works Help, ODP 210. And there's Course Deep, ODP 210. Right? This is a huge problem. This stuff is so available.
Are they taking Chegg's questions and then put on their own thing?
Possibly. I don't know what the relationship is.
4 times.
Well, but some of the, you know,
Who's the fastest? Let's find out.
yeah, so this one is the same question, so it might be, but I found others where there's actually a different question posted. And, you know, pay $5.90 to view the answer, right? So what are the issues with this, right? Well, first of all, code is always fingerprinted, right? You can look at a piece of code from somebody and you can tell that it's from that person because every coder has their own style and they leave fingerprints. And even if you change the variables and you change the indenting and that kind of stuff, it's pretty easy to identify someone's fingerprints, right? If you're a very good programmer and you've looked at a lot of code and written a lot of code and you know your own fingerprints, you may be able to take a piece of code and modify it to put in fingerprints that aren't the original coders or yours, but that's pretty hard to do.
Then at that point, it's not even worth the effort.
If you're able to do that, you can probably write ODP 410,
Yeah.
right? or 201 or whatever. So yeah, that's an issue. And so, you know, I find things like this and I'll go through and I'll look at the solution and I'll go through the submissions, and it's pretty easy to find who turned this in. And in most cases where I've done that, the person has already gotten a D or an F, not because they cheated, but because the code wasn't up to par, right? Because it didn't do what code had to do. Well, why is that? Because the written assignment says you must use the deletion algorithm as discussed in class, and we talk about it in class, and we go through examples, and we explain it, and we work it out on the board, and then they turn in code that uses a totally different deletion algorithm, right? That's a big red flag to me, and the first thing I do is I go off and I start looking to see if this matches something else. Because the person who actually wrote the code wasn't sitting here in class, wasn't doing the ODPs, wasn't listening to lecture, and so on and so forth. So it doesn't really work that well anyway, right? And it costs money, and the people who are writing this code for you get the money instead. And, you know, the thing that confuses me is where it ends. Because you can cheat your way through Clark, cheat your way through university, maybe get an internship and get somebody to write code for you there, and then get a job after graduation and get people to write your code on the job. And I know cases where this has happened. But sooner or later, you know, unless you become a professional outsourcer, this runs out, and there's nobody left to write code for you anymore. And what is going to happen at that point? Well, at that point, it's suddenly the midlife career change, and so it doesn't make a lot of sense in some cases, at least to me. The biggest problem with all this, though, is that it impacts other students. And so there's this thing called the imposter syndrome, right, which is this mistaken belief that the world looks like this, that I know a little bit and everybody else knows a whole lot. And it's a really easy thing to believe, especially when people around you are too afraid to ask questions. So I explain something really confusing, any questions, and you look and nobody's raising their hands. Well, I'm not going to raise my hand because I'm the only one who doesn't get it, right? But if you got people who are turning in a solution in 2 days, and yeah, I got an A on that, no problem, yeah, it was really easy to do, but they can't explain it to you because they didn't actually write the code. So you can't understand their explanations, right? It just feeds right into this. And the reality, of course, is that, we all know about the same amount of stuff, but different areas, right? So if this person in the middle talks to this person on the side, I only know this tiny little bit of what they know, Well, yeah, but the same is true of them. So this is closer to what the reality is. But this is so ubiquitous, right? When I was a grad student at Duke in math, everybody joked that they were the mistake, right? Everybody else belongs here. But when admissions got to my application, it was, Friday afternoon, everybody was in a rush to go home, and so they just rubber stamped it accepted. And I really shouldn't be here. And everybody felt that way. You eventually talk to somebody and was like, yeah, I thought that too. And it's self-feeding, You don't understand something, but you don't want to ask a question because you think everybody else does. And eventually you stop raising your hand. And you try to talk to your friends, and they don't really understand it, but they try to explain it, and you can't make sense out of it. So you stop asking your friends for help. And eventually one day you're like, I just don't want to come to class today, because I'm so tired of feeling like I'm the only person who doesn't get it, and it's just not helping me to come to class and sit there and be confused. So you don't come to class. And you do that for a few days, and then you come in and we're talking about something else, and it's like, well, I'm just too far behind. I'm just going to go home and work on this myself and read the book again and look at mine. And it just keeps snowballing, right? And the cheating problem is part of what feeds into this. And it's one of the reasons that this has to change. And on the teaching side, right, this can affect how or whether a teacher curves, because you hand out a ridiculously hard assignment and a group of students turn it in and get perfect working code on it, and you're like, well, I guess, I'm teaching them enough to do this, so I'm not going to curve the grade for these people who didn't do so well, And, you decide you're done talking about linked list because people seem to understand it based on their submissions, and we can probably pick up the pace now because we spent so much time talking about linked list. We'll go fast now, and I'll throw these questions on the exam. And after enough of this, especially year after year, you end up with a course where people who are cheating aren't learning anything because they're cheating. The people who are working aren't learning anything because the course has gotten geared towards the cheaters. And so it's going so fast and covering material so quickly that nobody can get anything out of it. And the course is just, sort of everybody wasting their time. So my prediction is 2 to 4 years, 2 to 5 years from now, this is all going to change. There's going to be a serious reworking of this whole methodology of computer science education, partially in response to these kinds of issues. But it's another reason you want to make sure you're not caught on the wrong side of that line. When somebody says, okay, we're going to do a big purge and we're going to have a clean slate here. And there's practical problems to this, right? I love automated bill payment. Computer programmers are the best, right? And you get this kind of stuff happening. This self-driving car sure is great. I bet the people who wrote the code learned a lot in school. This automated assistant sure is great. A personal assistant, play some music for me. Right? So, I mean, the people who are in school and getting degrees, they're the ones that are shaping our world in the future, right? Medical records and imaging and test results when you're in the hospital. Police records, academic records. What did you get in school? Did you even go to school? Have you actually been born? You know, all of this stuff. Our machinery, our cars are self-driving. Getting into our house is a negotiation with a piece of software. The future is so heavily software focused, and you really want like competent people writing this code. And it's getting to be more and more of an issue. And it's pretty well recognized by recruiters and hiring personnel and companies that seemingly increasingly people coming out of school with computer science degrees don't know how to program. And that's tragic, but it's also a huge opportunity for you, because if you come out with the ability to program, you're at the top, right? You're the ones that everybody's going to want to hire. So my only sort of suggestions for this are, you know, obviously watch out for the landmines. Try to avoid getting on the other side of that line where it looks like plagiarism is going on. Try not to get caught up in your head about where other people are or where they seem to be, right? If you've got people you're working with, if you've got allies, right, that's fine to like, you know, I really don't get this, I'm totally lost, I'm worried, that kind of thing. As long as it's someone that you trust and someone who can support you and you can support, that's totally fine. But the kind of groupthink of, you know, this class is ridiculous, we're all doomed, or, you know, looking at the people who seem to think that everybody should be able to do this really easily because, in fact, they're not even doing it themselves, they're just buying a solution or something. Don't get caught up in that, right? Just do your own thing. And people in here, through 224, right, I saw this incredible improvement in people's programming skills. And from PA1 to PA2, you're going to notice that yourself when we get to PA3 and so on. Some people I've been working with one-on-one, and it's really easy to see the solidifying of these concepts and people being more successful. Just keep going on that, all right? Follow your own path. Come to me if you've got questions, if you need help, if you have concerns or doubts. Talk to me, talk to your allies. And at the end of all of this, right, you're going to be awesome programmers, and you know, that's just going to work really well in the future. So, so that was kind of all I wanted to say, just sort of putting some information out there. I don't know if you have any questions or comments or concerns or anything like that.
Was that sure about the personal assistant?
Say what?
The personal assistant?
Yeah. Probably not, but hey, you never know. We thought it would be a good idea at the time.
It's a feature.
It's a feature, right? Undocumented features are good. All right. Well, I'll let you out a minute early. I will see you next time, and we will run through the GDB quiz and some of the other quizzes tomorrow. Yeah.
Was that actually you in that picture?
Was that what?
Was that you in that picture?
Yeah, that was me. That was my best friend Jimmy, and back in the 80s we built a digital camera, and so we took lots of pictures of ourselves.